Everyone. In this video, I'm going to be explaining Brain Facts Chapter 9, Slow Wave Sleep. So first, I just wanted to preface this saying that I know Brain Bee is approaching and it's getting closer, and you guys are probably cutting down on your sleep to prepare for this. But I'm here to tell you to not do that because sleep is critical for your health. Why? Because sleep deprivation is actually associated with diabetes, obesity, high blood pressure, and many, many more diseases, right? So this competition is not worth getting high blood pressure for. So I hope you guys are well rested. But on that topic, I wanted to introduce kind of the idea of brain states, right? So when you're awake or when you're sleeping or when you are doing an activity or when you are hyper focused on a task, each of these separate kind of actions are defined by a state of mind, right? The reason why you feel more tired after focusing on a task than leisurely watching TV is because your brain is actively using more energy in one brain state known as arousal rather than just in the early stages of sleep. So distinguishing between the modes that it's kind of like modes, right? That your brain switches in every now and then. So one mode that your brain has is known as sleep, right? So how do we recognize when your brain is in sleep mode? For that, we need to understand a technology known as EEGs, also known as electroencephalograms, right? So how electroencephalograms work is that there are electrodes that are glued onto your scalp, right? So you can see these electrodes over here and here located with different parts of the brain. So these electrodes over here would be correlated with an electrode over here, here, and here approximately, I believe. So basically, they kind of hover over the brain, but on the outside. And how electroencephalograms work is they, in your neurons, in chapter one, I hope you guys remember that there is always an influx of ions and then an exit of ions, right? And this is all electrical activity, right? This is all electrical activity. So if this is all electrical activity, your EEG basically records that electrical activity in specialized groups of neurons. So for this node, it'll record the groups of neurons right here. This electrode will record the activity for groups of neurons here, and so on and so forth. And why that's important is that groups of neurons actually work in synchronization. In other words, when one group of neuron is basically becoming, or when one group of or one neuron in that group is getting activated, the other neurons in the group are also getting activated, which leads to this peak. And then when they are deactivating, the ions all run out, which causes that dip in the electron waves, right? So I'm just going to erase this. Why that's important is because EEGs are really important to understanding brain states. In other words, based on the waves that are located in the EEG kind of diagram, what that shows is basically how neurons are being activated and deactivated, which tells us a lot about their state, right? So in sleep, you have something known as slow wave sleep, right? Where your neurons are going from depolarized or more excitable state to a hyperpolarized state, which is less excitable. So let's write that out, right? Depolarized means when more excitable, and then hyperpolarized means a non-excitable state. Or less excitable. I shouldn't say non-excitable. I should say less excitable state. So why that's important is because when you go from a more excitable state or when your neuron is depolarized or it's ready to be polarized, that means that there's not an influx of ions, right? So right now the um, membrane is more negative than it is positive. So basically this is when no influx of ions. And it's ready to receive more input. Whereas in a less excitable state, it's possible that um, there is an influx of ions, or it's in the refractory period, which is basically a period where your membrane potential becomes more negative to stop the action potential from occurring again, right? So make sure that you understand depolarized versus hyperpolarized. Depolarized means more excitable, hyperpolarized means less excitable. The way I like to remember that is that when a toddler is hyper, it's very hard to get them to get even more excited than they already are, right? Whereas when they're depolarized or when a toddler is tired, you can make them more excited by showing them candy. So that's how I like to think about it. So when toddlers are down, you can get them excited, but when they're hyper, you can't excite them anymore, right? So why is this all really important? Well, in a wakefulness state, this is the EEG readings for a wakeful state. So what we're seeing here is kind of a very interesting, very short waves, right? Their height is pretty much the same, very uniform. They're very short and they are very frequent. So there are words for this. There are terminologies that you should really know for this. So the first one is amplitude. So your amplitude is your height of the wave. And your frequency is how many times a wave occurs in a period. Number of times a period, or I could say even a duration or a duration of time. So to contextualize that, right? Notice how here the amplitude of all the waves are very short, right? The amplitude would be the highest point to the lowest point, and that amplitude is very, very small, which means that the neurons go from a depolarized to a hyperpolarized state very fast, right? So this tells me that neurons are depolarized and hyperpolarized fast, which means that your brain is getting activated very frequently. In this state, your brain is activated frequently. And that means that you're doing more thinking, right? So this means more thinking. And that makes sense, right? The more activity that you have, the more energy you're using here. However, slow wave sleep is when your brain starts to take that down a notch. You can see how the amplitude here is much, much larger, which shows here that um sorry about that, guys. So basically, what we see here is that your amplitude is very large, which means that your waves or your neurons are becoming depolarized to hyperpolarized much slower. Okay, so neurons are depolarized to hyperpolarizing slower, slower, which means you're not thinking as much, right? Which means you're not thinking too much. Not thinking as much. Which means you're relaxing, right? Which is why slow wave sleep basically accounts for this kind of really long, elongated time frames. And another thing that you need to see here, right, is that assuming that in this wakefulness state, right? Let's say that this is one wave. In this duration of time, you can see that there's almost 10 or 11 waves happening, whereas in this period, there's at max 2 waves or 2.5 waves happening. So the frequency of brain waves here is almost 10 to 11 hertz, which is basically waves per second, right? That's what hertz means. Whereas here it's 2.5 hertz, right? So 2.5 waves per second, which is really interesting because what that tells us is that slow wave sleep has a much larger amplitude and a much smaller frequency. So that's something you really, really need to understand, right? This concept between amplitude, frequency, and the amount of wake and state you have. Slow wave sleep has high or large amplitude, I should say. I'm going to abbreviate AMP as AMP, and low frequency, which is the exact opposite of your wakeful state, right? Here you have small amplitude and high frequency. So what does this mean in terms of dreams, right? So when you wake up in the middle of a SWS episode, what that tells you, what you're likely going to remember are fragments of thoughts. Fragments of thoughts. Because, as you can see here, you're not really doing much thinking, are you? You're doing very slow thinking. Your brain isn't working at its full capacity because its goal is to just relax in this state. It's not to do full-blown thinking like you're doing in wakefulness or even in REM sleep, which is going to be in the next video, which means that you're only going to remember bits and pieces of your dream, not full-blown vivid dreams like nightmares or something like that. So that is what you need to know about slow wave sleep. One thing actually that I'd like to add is that the longer you've been asleep, longer you've been asleep, I mean awake, you've been awake, the more your SWS will increase. Because how I like to think about it is that your SWS sleep is where you truly recover, right? I think of this as recovery sleep. Recovery. And another part of that, in conjunction actually, is that more time spent sleeping decreases your SWS. So just so you guys understand that correlation, the more time you've been awake, the more your SWS sleep increases. The duration or the time, your time will increase. Whereas the more time you spent sleeping or the more time you've been resting, the less SWS sleep you guys have. So this is all that you need to know regarding slow wave sleep. I've kind of condensed it into one video, and I've given you guys a brief explanation of electroencephalograms. I highly suggest that you also look at some demonstrations of how it works and some EEG kind of pictures to understand what you're kind of looking at. I know that there are a lot of great resources on YouTube. In addition, there are also some websites that I can link in the description below. But thank you so much for watching. If you have any questions, as always, please feel free to leave a comment or email me at stemwme@gmail.com. Thank you so much for your time. Bye, everyone.